circle. So if you are watching this because you missed class, I hope you will come if you have not already and pick up one of these blank piece of paper that looks like this so you can fill it in as you are watching this video. You also want to have a green, purple, and red pen and another color, be it pencil or blue also, because we'll be building this as we go along. And let's get started. So what is the unit circle? Well, first off, the unit circle is a circle that follows this equation, and that is a circle that is centered at the origin with a radius of 1, because we just finished our section on conics. So here is my y-axis and my x-axis. This is my origin. So this is my circle that has a radius of 1. Now, to start off with, we're going to talk about the measuring of angles. And everybody knows we got to have a place to start. So I told them that yes, but I told them that our zero measurement for circles is right here. Okay? That's where it always is, positive x-axis. All the way around, 360 degrees. Halfway between 0 and 360 is 180. So halfway around the circle would be 180 degrees. Again, if I'm going too quickly, just pause until you see me finish a certain color, and you'll know when you can move on. Halfway between 0 and 180 is 90. And then halfway between 180 and 360, or 90 plus 180, is going to be 270. Okay, so once you have those degrees established, I want to go back to the fact that we're on the unit circle. We are centered at the origin, so what are the coordinates of this point right here? And that point is 1, 0, which makes the point up top at 90 degrees, 0, 1. Continuing around to 180 would be negative 1, 0, and down below would be 0, negative 1. All right, so we have our basic points on the circle. This again is not going to be in red, green, or purple, but we have it in blue. So now we're going to go back to what we talked in yesterday's lesson, or the previous lesson before I talked about this, and that was our special right triangles. Now, if I take this special right triangle and put it on the unit circle, then you should know what this length is, because it's going to match up. It's going to match up, so it has a radius of 1 or a length of 1, and that is the hypotenuse of my triangle. Now, from our special right triangles, what side is opposite the smallest angle is the shortest, or the short leg, and that is always equal to 1/2 the hypotenuse. The long leg is equal to the short leg times the square root of 3, but we actually write that as square root of 3 over 2 instead of 1/2 times the square root of 3. Okay, now if you take this triangle and flip it and rotate it, you'll end up with that one. Same triangle, just in a different position, so my hypotenuse is still 1. The short side is opposite the smallest angle, so it is going to be 1/2, and the long side will be 1/2 times the square root of 3, or the square root of 3 over 2. Then we talked about our 45, 45, 90, and our hypotenuse is again 1. And this time, to get from the hypotenuse to the leg, to get from the leg to the hypotenuse, we multiply by the square root of 2. So to get from the hypotenuse to the leg, we're actually going to divide by the square root of 2. And when you rationalize that, that is what it looks like. So we're going to take these triangles and we're going to go build our unit circle with them. So first off, before I do that, I want to remind you which one is the first quadrant. So I hope you know that that is the top right, and the signs of the coordinates in that quadrant are positive, positive. And then moving in a counterclockwise direction, that is quadrant 2, where it's negative and then positive, and then quadrant 3, which is negative, negative, and quadrant 4, which is positive, negative. Okay, so now that we have that, and we have refreshed your memory, we're going to take these triangles and put them on our unit circle. So the first one we have is the red one, which is our 30, 60, 90 triangle. All right, so we know that this was one, we just talked about this. This is the short side, this is the long side. That angle has to be 30 degrees, And now we know that we went over the long amount, which was the square root of 3 over 2, and up the short side, which is 1/2. Now, if I take this triangle and I flip it and slide it in here, then what's going to change? Well, first off, this angle right here is 30 degrees, but you have to name it from here to here. So you should be thinking, what's 30 degrees before 180? And what's going to happen to these coordinates when I put them in the second quadrant? Because I'm at the same spot with my triangle. So 30 degrees before 180 is 150. And then my coordinates are going to be negative square root of 3 over 2, comma 1/2. If I take that triangle and flip it, and I now go, this angle is again 30 degrees, and now I'm at a point that's 30 degrees after 180, and that is 210. And now my coordinates will both be negative, so we'll have the negative square root of 3 over 2, comma negative 1/2. And then last, if I take that and flip it again to slide it in here, I now, at this spot, with this 30-degree angle, am 30 degrees before 360, which is 330, and my coordinates will be positive square root of 3 over 2, comma negative 1/2. All right, I should have told you to pick up your red pen, and now I'm going to tell you to put down your red pen and pick up your purple pen. And we're going to go with the purple triangle. The purple triangle, that was our 45, 45, 90. So this is going to be right here it's going to be 45 degrees, and each side length was the same, and that was the square root of 2 over 2, comma square root of 2 over 2. Now if I flip that and put it into the second quadrant, I am looking, that's my 45-degree angle. These angles, y'all, in our triangle are always made with the x-axis. So that's 45 degrees, and I need 45 degrees before 180, which is 135. Again, the x-coordinate of the pair is negative, and the y is positive. Now take it and flip it, put it in the third quadrant. 45 degrees after 180 is 225, and both coordinates will be negative. Negative square root of 2 over 2, comma negative square root of 2 over 2. And then last, in our fourth quadrant, we have 45 degrees before 360, which is 315, and positive square root of 2 over 2, comma negative square root of 2 over 2. Okay, got that down, pause if you need to, and now put down the purple pen and pick up the green one. And now we're going to put the green triangle on here. So my 30-degree angle is now up here, and my 60-degree angle is here. So that means up here is going to be 60 degrees. This is my short side, that's my x-coordinate, so that is 1/2, and this is going to be square root of 3 over 2. And if I take my triangle and I flip it over, put it into the second quadrant, then I need this angle here is 60 degrees, and 60 degrees before 180 is 120. Again, negative 1/2, comma square root of 3 over 2. Then I'm going to take my triangle and I'm going to flip it, put it down on the bottom, and I need an angle that is 60 degrees after 180, and that is 240. Both coordinates are negative, negative 1/2, comma, negative square root of 3 over 2. And then into the last quadrant, I flip it again my 60-degree angle. This is 60 degrees before 360, which is 300. And my coordinates will be positive, negative, so I have positive 1/2, comma, negative square root of 3 over 2. Okay, so next thing we talked about is we have just measured this circle and put all these on here for degrees. There is another way to measure angles, just like there's another way to measure segments with inches and centimeters and feet and whatever. So the other unit of measure talking about is this unit of measure for this angle when the radius of the circle is equal to the arc length that is cut off by the angle. Because this is obviously, this has a length of r because that's the radius, this has a length of r, and this has a length of r. And when they all have that same length, then we say that that measure of that angle is 1 radian. Okay? Now, if you can think about it, I asked them, I said, how many radians does it take to go all the way around the circle? Not many successes, a lot of guesses. A lot of people guessed close to 6. But if you remember, what is the distance all the way around the circle? Well, it's 2 pi times the radius, and my radius is 1. So this is why to go all the way around the circle is actually 2 pi radians. So we're going to put radians on there. So pick up the first one, which was not red, green, or purple. I have it in blue. All right, 0 in any unit of measure is 0. So 0 degrees is still 0 radians. And you do not have to write the R. I just put it there so you knew what we were doing. All the way around, as I just mentioned, is 2 pi. So halfway around over here is going to be pi. And halfway between 0 and pi is 1/2 pi. Well, that, of course, is written as pi over 2, which makes this down here 1.5 pi, but we write that as 3 pi over 2. Okay, now let's pick up, I'm going to go to the green one. So pick up your green pen. And basically what I want you to look at is the top, actually not the green one, let's go to the purple one, my bad. Go to the purple. If this is pi over 2, okay, and this is 0, what is halfway between 0 and 1/2 pi? Well, I said 1/4 because that's what that is right there. That is 1/4 of pi. So if you think about it, this is 0, this is 1/4, this is 2/4, but we don't write it as 2/4 because that reduces to 1/2. And then we're going to have 3/4. And then we're going to have 4/4, which is pi. Then we're going to have 5/4, and then 6/4, and then 7/4. Okay? So the fourths that we're going to have on our circle are the ones that don't reduce. Okay? But what's important is for you to think of the fact that I'm taking half of this and cut it into 4 equal parts, and that's why that one is 5 and 4. Now pick up the green one. Okay, I'm going between 1/2 and 1/4, but if you can see, hopefully you can tell, but if I take this half of the circle and divide it into this and this, that has cut my circle, that half of the circle, into thirds. So that is 1/3 pi, and over here is going to be 2/3 pi. Down here is 3/3 pi, which makes down here 4/3 pi, and then 5/3 pi, and then 6/3 pi, because 6/3 of course reduces to 2. Alright, so the last one we have is pick up your red pen, and this one is smaller than a fourth, so if I cut it into fourths, so people guessed 1/5 or 1/6, and of course it is 1/6. So this is pi over 6, and this part is equal to that part. Well, that's 2 pi over 6, but that reduces to pi over 3. Then you have 3 pi over 6, which is pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6, and you guessed it, 11 pi over 6. So I did that so that you would understand where it comes from. But I'm telling you that if you know these right here, I'm going to tell you an easy way to remember all of them. Okay, if you know these three, or this quadrant basically, okay, they're color coded. So anything that's red is going to be over 6. Anything purple's over 4. Anything green's over 3. Okay, this quadrant, the top is always 1 less than the bottom. 2 is 1 less than 3. 3 is 1 less than 4. 5 is 1 less than 6. So everything in this quadrant in the radians that you have to know for a unit circle is 1 less. Down here, everything is 1 more. 7 is 1 more than 6. 5, 1 more than 4. 4, 1 more than 3. And then when you get to this one, somebody pointed out to me, which I kind of like, if you go across to the color-coded one, okay, if you add 2 and 3 together, that's the top over here. So on the purple one, if I add 3 and 4 together, that's the top over here. And then add 5 and 6 together, and you get the top over here. Okay, so that was to hopefully help you remember. And if you forget anything, I hope you or don't understand anything, please come by and see me. But this is a we've done. So we talked about what the quadrants were, what their names were. We put the angles and the coordinates on each one. So this is kind of a screen that's going to help you check your unit circle and make sure you have everything. All right, then I put my 30-degree angles, the red ones, with their coordinates. Then we have 45-degree angles with their coordinates. And then we have 60-degree angles with their coordinates. Then I came back on the blue ones, I added the radians. And then we added the red radians and purple radians and the green radians. Okay? More importantly, why do we care? What is so important about this unit circle? Well, what the big deal about this unit circle is, these give us the value of any trig functions on this unit circle. Okay? And so we have, if you can remember, okay, obviously this is an ordered pair. This is x, this is y. Okay? Goes in the same alphabetical order, cosine and then sine. How do I use this? What happens is, if you think back on this red triangle that we have here, okay, this is 30 degrees. Well, how do I find the cosine of that angle? I'm going to take the adjacent side and put it over the hypotenuse. Well, the adjacent side is the square root of 3 over 2, and the hypotenuse is 1. And since the hypotenuse is 1 for all of these values, then the first coordinate of the ordered pair gives me the cosine of that angle. So the cosine of 30 degrees is the square root of 3 over 2. And the sine of 30 degrees is 1/2. So I had a worksheet that I gave out that you'll need to come by and you can get off our calendar in Canvas. So to practice reading the unit circle. So if I asked you for the cosine of 90 degrees, you would go to 90 degrees. You would go to the first coordinate, because the first coordinate is cosine. Cosine of 90 degrees is 0. If I asked you for the sine of 225 degrees, you would find 225 degrees. And the sine is the second coordinate, so the answer is negative square root of 2 over 2. So the next thing we talked about, so there's lots of them. You need to practice with the worksheet that you were given, and come see me if you have any difficulty or don't understand that. The other ones that we talked about to help you remember is sometimes you'll be asked to find the tangent. Okay, so again, if you go back to our red triangle that was here, tangent of this angle is opposite over adjacent. Well, opposite is my y and adjacent is my x, which is like saying it's the sine over the cosine. So the tangent of any angle is the sine over the cosine. Now let me tell you when you're evaluating that. Okay, so the tangent of 90 degrees is sine over cosine. 1 over 0 is undefined. So the tangent of 90 degrees is undefined. What if I ask for the tangent of 180 degrees? The tangent is sine over cosine. 0 over negative 1 is 0. So the tangent of 180 degrees is 0. What if I ask for the tangent of 45 degrees? Okay, so when you get to any of these here that are these kind of messy looking fractions, you might think, notice that all of the denominators of these things are 2. So I'm telling you to simplify your life, to find the tangent, you can ignore the 2 because it's going to simplify out. So all you have to do is put the square root of 2 over the square root of 2. Square root of 2 over square root of 2 is 1. So the tangent of 45 degrees is 1. What about the tangent of 5 pi over 3? Well, where's 5 pi over 3? Pi over 3 is green. 5 pi over 3 is down here. The tangent is sine over cosine. So it's the negative square root of 3 over 1. So the tangent of 5 pi over 3 is negative square root of 3. Okay? Now, the last thing to talk about are the reciprocal functions, okay, that we talked about in our lesson yesterday. And the reciprocal of the tangent is the cotangent. So if the tangent takes the sine over the cosine, then hopefully you realize that the cotangent will be the cosine over the sine. So if I wanted the cotangent of 90 degrees, I'm going to take 0 and put it over 1, which will be 0. Okay? So again, we need to practice those a lot. The last thing I talked about them is what if I have to find the secant or the cosecant. All right, those are more of the reciprocal functions. Okay, which I said reciprocal before. Anyway, but let's just go with this. So we have a chart here that I made because all of these numbers are the same. So you can go do this the long way, or sometimes it's easier just to memorize this chart of reciprocal values. So if I need to find the secant of pi, I'm going to go find pi. Pi is right here. Secant is 1 over the cosine. The cosine is the x-coordinate. So what is 1 over negative 1? Well, hopefully you answered negative 1, which is what this chart is telling you. That the reciprocal of 1 is 1. If it's negative 1, it's negative 1. Okay? So all of these are just the numbers that you're going to take the reciprocal of. What's 1 over 0? We've already talked about that. That's undefined. Well, if you see undefined and you need the reciprocal of it, I hope you'll remember that's 1, that's 0. Okay? You know the reciprocal of 1/2, if I flip it, is 2. These two, you already know, they're on there as tangent values, so you're going to run across them. But I think y'all know, if I take the reciprocal of this, if I say 1 over the square root of 3, y'all immediately know that it's the square root of 3 over 3. So these two are reciprocals of each other. So hopefully that's enough to tell you what's the reciprocal of this. The reciprocal of square root of 3 over 3 is square root of 3. The reciprocal of the square root of 2 over 2 is square root of 2. So the last one, the only one that's kind of hard to remember is this one right here. But if you flip it, that makes it 2 over the square root of 3, and then you rationalize it, it becomes 2 square roots of 3 over 3. So just a chart that I like to write down when I have to evaluate things, and then I don't have to stop and actually calculate when I'm doing reciprocal values. Okay? And the last thing that I told them in class was I showed them what the copy of their quiz is like. Again, it's in Canvas, and I put a link to this game in Canvas to help you practice. So I hope that helps for those of you who are absent. Now let's see if I can get it into a format that you can watch it. Come see me if you have any questions. Thank you.
Okay, so watch the other video to get some examples of how the game works and to see me do some examples of your Otsua. Please attend the live Q&A on Monday if you have any additional questions. Thank you.